Hi everyone. Given A is related to B, if and only if A squared is equivalent to B squared mod 2, prove that R is an equivalence relation on the set N, natural numbers. And then we have two equivalence classes. Anytime you see this number, that's the number of equivalence classes. So let's prove first it's an equivalence relation by proving these three conditions. So the first one we're going to prove is reflexive. So that means that A is related to B if and only if A squared is equivalent to B squared mod 2. So that means if you rewrite it, it just means A squared minus B squared equals 2m. That means that when you divide by b, your remainder is 2. So if you have x, something like this, you can rewrite it as x minus y equals 2m. So that means you divide, y is your divisor, and 2 is your remainder. So let's we write it like this to do our proving. So now, if we do A is related to A, this is true because A squared minus A squared equals 2m, and that would be m equals 0. So it's reflexive. All right, and then for some symmetry, we do the same thing. We're going to write A is related to B if and only if A squared minus B squared equals 2m. That implies that B squared, this does, minus A squared equals negative 2m. Now, if you want, you can write this as B squared minus A squared equals 2n, where n equals negative m, and n is an integer. All right, therefore b, let's write it here, b is related to A. All right, now we have to do the transitive part. So for the transitive part, we have to make up some values. So let's do A is related to B if and only if A squared minus B squared equals 2m. And we can also say B is related to C. We're going to have to add a C to do transitive. If and only if B squared minus C squared equals 2, let's call it n. M and n are integers. All right. So now let's add all this together. And you're going to get A squared minus B squared plus B squared minus C squared equals 2m plus 2n. So these two will cancel and you get A squared minus B squared equals, pull out the 2, m plus n. Now if you want, call this P. So P equals m plus n, where P is an integer. And therefore we have A is related to C. So we have that it is transitive. So we prove that. And that's how you would prove it. You keep condensing these right here. All right. Now we have to find the equivalence classes. So let's start with 0. So we know 0 squared equals 0 mod 2. And 1 squared equals 1 mod 2. Okay, let's do some more. 2 squared goes back to 0 mod 2. because if you divide by 2, 4 divided by 2 is 2, and there's no remainder. So that's 0. And then let's do 3 squared equals, we do mod 2 here. So if you take 9 and divide it by 2, you're going to get 4 and remainder 1. So that your remainder is 1. If you notice here what's happening, you have 4 squared is going to be 0 mod 2. 5 squared equals 1 mod 2. So if you notice, our equivalence classes, our 2 equivalence classes, are the ones that look the same here. So one equivalence class is going to be 0, 2, 4, and then you can just keep adding 6. We just needed to write enough down to find a pattern. And another one is where you have the 1 mod 2. So these. So that would be 1, 3, and 5, your odd numbers. Because anytime you divide an odd number by 2, your remainder is 1. And those are your 2 equivalence classes. Thank you. Have a nice day. Bye-bye.